Hello everyone. Hope you are happy and healthy. Let us learn a new chapter. We will study chapter number 5, periodic classification of elements. Before we begin this chapter, let us recall what we have learned in standard 9 about elements. In standard 9, we learnt about matter around us. We also learnt, is matter around us pure? We know that the matter around us is present in the form of elements, compounds, and mixtures. And the elements contain atoms which are only of one type, which means elements have single type of atom. Do you know how many elements are known till date? Here is the answer for you. At present, 118 elements are known to us. All these have different properties. Out of these 118 elements, 94 elements are naturally occurring. Other elements are made by chemical reactions. As different elements were being discovered, scientists gathered more and more information about the properties of these elements. As the scientists found the elements, they learnt their properties also. But there was a problem. What was it? Scientists found it difficult to organize all that was known about the elements. They got different properties of different elements, but they were not able to organize in a proper sequence. So, what were they doing? They started looking for some pattern in their properties, so that on the basis of their similarities or differences, these elements can be arranged in proper sequence, or else we can say that on the basis of their properties, the elements can be organized. So in this chapter we will learn the organization of elements, how different scientists have given their different organization of elements. So each of them we will learn in detail. Let us start it by taking an example. When you go to a chocolate shop, you will find that the chocolates are arranged properly. In that arrangement also, you will see that the chocolates of same company are placed together. So there you will see the organization, which means in the store also we see organization of the things. On the second instance, we can take that when we visit a mall. There, all the edible items have separate stalls. You will find that all the biscuits are arranged in a different shelf. There also different products of different companies are organized properly. We don't see that all the things, whether they are biscuits or chocolates or any other edible items, all they are mixed, that we never see. Everything is organized properly. Let me give you more clarity. In the shop, soaps are kept together at one place. In that also, bathing soaps are different than the washing soaps. From this all examples, I wanted to say you that all the things are organized properly. Similarly, scientists made many attempts to classify elements according to their properties and obtain an orderly arrangement out of this problem. So now we will learn what type of arrangements did they make and who were the scientists who have contributed for arranging the elements based on their property. So let us now begin. First of all, we will learn Dobereiner's triads. In the year 1817, Johann Wolfgang Dobereiner, please remember the name of the scientist. Here he is a chemist. Johann Wolfgang Dobereiner. Simply, if we'll remember Dobereiner, then also it will work. But better to know the full name. Dobereiner was a German chemist. He tried to arrange the elements with similar properties into groups. So, what type of arrangement did he make? He took these elements and he got the similar properties in some elements. So, what did he do? All the similar properties elements he placed in one group. This way, he made groups. He identified some groups having 3 elements each. So he called these groups as triads. These names you need to remember. So now let us learn about it. He found that each group has 3 elements and each group has the elements which are having similar properties. Dobereiner showed that when the 3 elements in a triad were written in the order of increasing atomic masses. What does it mean by atomic mass? We have learned in standard 9. Atomic mass is the number of proton plus number of neutron. The atomic mass of the middle element was roughly the average of the atomic masses of other 2 elements. This is the Dobereiner's triads. In simple way, let us understand by using this table. He has classified elements into groups. Now, in these groups, he got nearly 3 elements in one group. Okay, now what he said, if we arrange the elements in increasing order of atomic masses, then what he said, the atomic mass of the middle element was roughly the average of the atomic masses of the other 2 elements. This is what Dobereiner's triad rule. Now, see, first group. It has lithium, sodium, potassium. Okay? Now, we are learning by taking this example. It has atomic masses. Lithium has 6.9, sodium has 23.0 and potassium has 39.1. Now, according to Dobereiner's triad, what he said that the average of first and third element's atomic mass will be equal to the middle one. Okay, so if we add 6.9 plus 39.1 and divide by 2, then we will get answer roughly as 23. Are you getting what I am saying? He said that the atomic mass of the middle element. Here what is the middle element? Sodium. What is its atomic mass? 23. So that will be roughly equal to the average of other 2 elements. What are the two elements here? Lithium and potassium. What is the atomic mass of lithium? 6.9. What is atomic mass of potassium? 39.1. So this way he arranged these elements into triads. Triads, tri means 3. So triads will have 3 elements. In simple way you can remember. Let us understand the second group. It has calcium, Ca, that is calcium. Then we have Sr, that is strontium, and Ba, that is barium. Atomic masses are given. Atomic mass of calcium is 40.1, strontium has atomic mass 87.6, and barium has 137.3. Now, what is Dobereiner's triads rule? The atomic mass of the middle element. Before that, the masses should be arranged in which order? Increasing order. So here they are arranged. The atomic mass of the middle element is equal to the average of other two elements, which means 40.1 plus 137.3. This total divide by 2, then it will give us nearly equal to 87.6. Same way, let us take the third group also. In third group, first element is chlorine. It has atomic mass of 35.5. Then bromine, which has atomic mass 79.9. Then third is iodine, which has atomic mass 126.9. Now, these elements are included in the Dobereiner's triad, which means they must be arranged in increasing order. So, here they are. Then, the atomic mass of the middle element, that is bromine, that is equal to the average of chlorine and iodine's atomic mass. So, when we do 35.5 plus 126.9, and these total divide by 2, then we get roughly 79.9. So this is about Dobereiner's triad. It is very much easy. Tri means 3. And what did he do? He arranged these elements in their increasing order, and then he said increasing order of atomic mass, and then he said atomic mass of the middle element will be roughly the average of atomic masses of other two elements. Now we'll have another group table number 5.1. Here some groups of 3 elements are given. These elements are arranged in order of increasing atomic masses. We have to find which of these groups are from Dobereiner's triads. Here in this table, triads are given. Also, they are arranged in increasing order of atomic masses. We have to find which is from Dobereiner's triad. How will you find? We can find by the remembering the rule, which is in Dobereiner's triad, the atomic mass of the middle element that should be nearly the average of first and third elements' atomic masses. So, when you will do this for group A, B and C, you will find that from these 3 groups, group B, which has calcium, strontium and barium, that is the group from Dobereiner's triads. Now you will be thinking, why we have these 3 groups only in Dobereiner's triads? Because Dobereiner could identify only these 3 triads from the elements which were known that time. And that is why this system of classification which Dobereiner has given, that is triads, that was not found to be useful. because how many elements were known that time, from that he could identify these three groups only. So this was not useful.